This is a demonstration of the Orbit.io System Planner in which I show how to plan and optimize connectivity between a die and a package in the context of a printed circuit board. I start with a board that has two memories with their data bits broken out and two BGAs. The BGA on the right and the memories on the left were in the original board file in Allegro PCB and were imported into Orbit.io as a reference point to assist in the optimization of the center BGA pins and die bumps. The center BGA was created dynamically in Orbit.io, and the die was created in Cadence Encounter Digital Implementation System place and route environment and transferred to Orbit.io as a die abstract. The center BGA and die both have been assigned personality patterns consisting of signal, VDD, and VSS personalities. 7 interfaces have been defined. These interfaces span all fabrics in the design. Interfaces may be hierarchical. As I select these interfaces, you can see where they have been planned in the system. I will use these interfaces to plan from the PCB up to the die and from the die down to the package. I will use bundling to manage the connection between these different devices and fabrics. I will begin by creating a bundle for DDR Bank 1 from the breakout routing endpoints to the signals in the middle BGA. Notice how the bundle comes off the breakout routes. The route lines come into the bundle in a specific order based on the breakouts and maintain the same order as they flow to the BGA. Pins are optimized based on the pin order in the bundle. This is especially significant if you don't have a straight line between devices. I now create a bundle from the BGA to the die. In the end, this gives me net assignments on the BGA and on the die that are in order based on the memory breakout routes. This will significantly simplify the routing in the PCB and in the package. I complete the bundling process for the other interfaces with a script. The EM and VID interfaces are created from the board to the package and die. And finally, the 3 bundles on the bottom are driven from the die to the package. I will now explain how to further optimize the design using floor plans and bundles. Floor plans of equal sizes may be swapped. I can swap the pins in the die between Bank 0 and Bank 1. I can also swap the floor plans on the package. Although I don't show it here, you can move floor plans, swap pins, add power and ground pins, and manage signal, power, and ground ratios through interfaces. I will now show breakout route feasibility that may be used to manage the ordering of pins. I specify the layer it will be routed on and define a 30 micron width and spacing rule. I apply the rule to each of the pins, and please note that I can specify multiple rules and apply them to different pins in the bundle. I then run a trial route to see if the signals can be routed out to the edge of the die. I can also change the order the signals are broken out of the device, or I can swap pins on the device. Each time it is simple to rerun the feasibility route. This process can be used on each end of each bundle to untangle and optimize the nets between each component in the system. Any net assignment changes on the bumps will be passed back to Encounter through the die abstract. Once I am satisfied with the pin assignments and net ordering in the bundle, I save the design and load it into SIP Layout for package layout implementation. This integration provides a convenient mechanism to clearly communicate design intent to downstream design resources, whether they're internal or external, like an OSAT. SIP Layout reads the BGA, the die abstract, the bundles, layer assignments, and pin assignments. The results from Orbit.io are now available to drive actual breakout routing and implementation in SIP Layout. I do the breakout routing with Cadence's Auto Interactive Breakout Technology, or AIBT. In summary, I have shown how Orbit.io provides a single canvas in which I can perform chip, package, board planning and optimization. And then the results from Orbit.io drive physical implementation in SIP Layout. If you are interested in learning more about this or similar flows, please contact your sales representative.